Good morning or good afternoon, everybody. We're going to start section 6.2 today and go over some sum and difference formulas. But first, just to kind of get a review of yesterday, why don't you copy down this identity and let's verify it. I'm going to give you a little bit of time here and I'll give you a little bit of clue. Go ahead and convert everything to sines and cosines and just see if you can get this one on your own. I'm going to pause this, or you go ahead and pause this. Try this and then see what you come up with and then turn it back on to see if you were correct. If you get stuck, obviously go ahead and restart it and you'll see where you're at. But I'm going to go ahead and do it right now. Like I said, convert everything to sines and cosines. All right, so what you got is cosecant is going to be 1 over sine of x plus cotangent, which is going to be cosine of x over sine of x. And that is all going to be over the 2 here, tangent, which is sine of x over cosine of x plus sine of x. And we talk about with fractions, it might not hurt to do this now. That's just sine of x over 1. I'm going to go ahead and mess with this right-hand side here. Cosecant is 1 over sine of x times cosine, which is, cotangent, which is cosine over sine. All right, since we're multiplying over here, I can group or combine these a little bit easier. Multiply your numerators, you get cosine of x over sine squared of x. All right, I'm going to leave this for now and then just kind of see if I need to change anything later. All right, back here to the left-hand side, we're going to have to get a common denominator in the numerator and the denominator here. So you got basically 2 pieces to this. Well, actually in the numerator, we already have a common denominator. So I can add those together. So that's going to become 1 plus cosine of x over sine of x all over. All right, we got sine of x over cosine of x. No, let me do something here. See if I can get rid of both of those now. Okay, sine of x over cosine of x plus sine of x over 1. What I need to do is multiply that one by cosine of x over cosine of x in order to get the same denominator. And so I'll have sine of x over cosine of x plus sine of x times cosine of x all over cosine of x. All right, now I got 1 plus cosine of x over sine of x all over, then I can write this as sine of x plus sine of x cosine of x all over cosine of x. All right, going to kind of do 2 things at once here. There's your numerator. Here's your denominator. I'm going to multiply those together. I'm going to keep change and flip. But as I do that, this top here, notice what do they have in common? They both have a sine of x. I'm going to factor out the sine of x, and that's going to give me 1 plus cosine of x. Okay, for that particular numerator. So when I keep the top one, it gives me 1 plus, nope, let me switch that. It's going to be 1 plus cosine of x over sine of x. Okay, multiply, flip the bottom one. That means the cosine of x will go in the numerator. And then I get sine of x times 1 plus cosine of x. That's because we factored that out. All right, now we're always looking for things to cancel. I can cancel this 1 plus cosine of x with 1 plus cosine of x. We're left with cosine of x from right here. And then I got sine of x times sine of x, which is sine squared of x. Okay, so there's that identity. A couple of things that come up a ton are when you have two fractions, getting a common denominator, and then having a fraction over a fraction, being able to multiply those two together, keep, change, flip. And then we got our final answer there, cosine of x over sine squared, which matches up the other side. All right, so just another identity, making sure you're okay with those. All right, we are moving into section 6.2. Section 6.2 is sum and difference identities. And go ahead and get out that identity sheet that you had that I gave out yesterday or the day before, the one with all the equations on there. And on the right-hand side, you'll see the sum and difference identities. That's what we're going to work with today. All right, so to start with, then this is just going to show you how it works. So if you take a look at that very top, I believe this is the very top equation. Cosine of alpha plus beta equals cosine of alpha times cosine of beta minus sine of alpha sine of beta. We're going to use that to find the exact value of cosine of 75. All right, to this point, we can only find the exact values for unit circle angles. So what I mean by that is we can figure out the cosine of 45 degrees. And this is what we went over in our the little trick quizzes we were doing. That's square root of 2 over 2. You know that the cosine of 120 degrees. All right, so as you think about that, cosine, where it's at, draw it out if you need to. Gives me a reference angle of 60. That means that the cosine of 120 degrees is going to be negative 1/2. But we can only find 30, 45, or multiples of 30 and 45 at this point. So we're limited on the exact values we can find. So we want to come up with other methods to find other angles. And this is one of those things. So for the cosine of 75, I'm going to break that down. We have to break it down into angles that we know. So 75 is the same as 30 plus 45. So to find the cosine of 70 degrees, I'm going to use this formula with 30 and 45. Well, sometimes it's helpful to think of this as first angle, and this is second angle. So it's going to be the cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. Okay, so 30 degrees is my first angle, and it really doesn't matter which is first or second as long as I follow the formula. So it's going to become cosine of 30 times cosine of 45 minus sine of 30 degrees times sine of 45 degrees. Well, we know how to take all of these. Okay, that's what we spend a lot of time doing the trig work on. All right, so cosine of 30, go through your unit circle if you need to. Understand where the opposite, adjacent, and hypotenuse are. And so cosine of 30 is going to be 1/2. Actually, hold on here. Let me double check. So that's 30. Nope, cosine of 30 is square root of 3 over 2 because the 1/2 would go here. All right, cosine of 45, square root of 2 over 2, minus sine of 30 degrees. Sine of 30 degrees is 1/2. Sine of 45 degrees, square root of 2 over 2. All right, now this isn't going to simplify very nicely, and that's okay. All right, to multiply these together, multiply the tops together and the bottoms together, you can multiply square root of 3 times square root of 2. Square root of 6, 2 times 2 is 4. Same thing here. Okay, that's going to give me minus 1 times square root of 2 is square root of 2 over 4. They both have a denominator of 4. So I got square root of 6 minus square root of 2 over 4. That is going to be the cosine of 75 degrees. All right, just to make sure this makes sense. Cosine of 75 degrees. If I go to my calculator, let me make sure I'm in the right mode. Degrees. It's this decimal, 0.2588. That's an irrational number. Can't be represented by a fraction. So I have to be able to keep it in terms of radicals. All right, so if you take a look here, square root of 6 minus square root of 2. And I'm going to take, hit enter on that. And then if I divide that by 4, I'm going to get the same value. So now I can start representing or finding the exact values of some other numbers. To this point, we could only do multiples of 30 and 45, only the unit circle angles. This is going to allow us to do others. Now here's the big question. Where did this formula come from? Okay, where did that formula come from? And why does it work? Well, since you want to know, I will show you. All right, so we know that formula right here. Now, in order to figure out where these formulas come, it's helpful to know these cofunction relationships. Sine of negative theta is negative sine of theta because it is an odd function. Cosine is an even function, so cosine of negative theta equals cosine of theta. Sine of 90 minus theta is equivalent to cosine of theta, and cosine of 90 minus theta is equal to sine of theta. Those are going to come up. All right, for this very first one, it is a little bit long and it's a little bit difficult, and you should have a paper here that hopefully is the substitute handed out. You do not have to memorize this. This is just to give you an idea how to do this. It'll be a little bit difficult for me to explain here. Might have to do it again when I get back. But this is how we prove that first formula. Okay, if you take this circle, now here's an angle alpha, here's an angle beta. To help us out, all I do is take that angle and I make negative beta on the other side. So they got to be equivalent. Okay, so if that's 22 degrees, that's negative 22. If that's 52 degrees, that's negative 52. All right. Hopefully it makes sense here that this angle, which would be alpha plus beta, will be equivalent to this angle, which is alpha plus negative beta. Those two angles have to be the same. If two central angles are the same, that means that they're, hold on one second. That means that their arcs, which would be arc AC and arc BC, or BD, have to be the same. And if you have arcs that are the same, that means you have segments that are the same. Now those segments, AC and BD, are what we call chords. So that's the first part of the proof. Those two arcs have to be the same, and from geometry, that means those two chords have to be the same. Now we got a good bit of math going on here. We are going to show, okay, the rest of this proof basically shows that this, using that chord AC is equal to BD. I'm going to use the distance formula using these points to show that they're equivalent. Well, this is a unit circle. That point C, that is 1, 0. Point B, that is cosine of the angle for the x value, sine of the angle for the y value. So cosine alpha, sine alpha. This point right here, A, well, this whole angle, so it's cosine of alpha plus beta times comma sine of alpha plus beta. And then point D right here, that's just this negative beta and sine of negative beta. Well, cosine of negative beta, from what we did just on the previous slide, cosine of a negative of an angle is the same as the cosine of the angle, while the sine is the opposite. So that's how we get this. All right, essentially, we're going to go through here. This step right here uses a distance formula with points A and C. This right here uses a distance formula with points B and D. Okay, so cosine, so that's the x value, cosine of alpha plus beta, which is right here. This is going to be, see if I can get that to where I can see it. Cosine of alpha plus beta, which is here, minus 1. Okay, and then that's, x2 minus x1 squared plus, and then you take y2 minus y1 squared. All right, well, this whole rest of the way, there's a whole bunch of algebra going on, which I did try to demonstrate what's going on. But in the end, as you go through this whole thing, this is what we end up with. Cosine of alpha plus beta equals cosine alpha, cosine beta, minus sine alpha, sine beta. Well, QED, what is that? Because I'm sure you're asking. So I'll tell you. QED is an abbreviation of the Latin phrase. Let's see if I don't butcher this. Quod erat demonstratum, literally, which means which was to be demonstrated. And figuratively, I rest my case. The phrase is written in an abbreviated form at the end of a mathematical proof to signify that the last statement deduced was the one to be demonstrated. So the proof is complete. Basically, you're saying, I am done. You do not have to put that on your proofs. That is just a little fun fact. Okay, there are 3 others as you look there. I'm going to do something here. You got your sum and difference formulas at the top of that paper. This is the first one. We just went through that on that very long proof. We're going to show you how to do the other ones, but we don't have to go through the long one because we already know this one. Here's how this works. To prove anything is true, so like if I want to prove this is true, I can use any statement above it or to the left. Well, if you look to the left on that sheet, you have all those other statements. We've already proven those to be true or accept those to be true. So I can use those, and I can use this one right here. I cannot use anything below it. Okay, so that's kind of the rule. To show anything is true, you can use anything above it and to the left. All right. Let's go to here, and we are going to prove the next one. You will be responsible for this on quizzes or tests as we move forward. Now, this one is really, once we did the long one, okay, this long one here is going to make our life a lot easier. Okay, so that is true. We know that this one is true. All right, this needs to be our final thing that we prove. All right, so here's the proof. All right, we are going to start with cosine of alpha minus beta. Okay, and what we are going to do is we're just going to rewrite alpha minus beta in terms of a plus sign. So what that means is I'm just going to rewrite that as cosine of alpha plus negative, plus negative beta. Okay, that's equivalent because if you simplify that. Now, here's the reason we do this is because I can now use that formula that we just proved, and it is above it. Okay, the formula says cosine of alpha plus beta equals cosine of the first times cosine of the second minus sine of the first angle times sine of the second. I can use that. Here's how we're going to use that. So cosine of alpha minus beta is equal to, all right, this is a sum. My first angle is alpha. My second angle is negative beta. I can use this formula up here. My first angle will be alpha. My second angle will be negative beta. So I'm going to rewrite this. And then so cosine of alpha plus negative beta is the cosine of the first angle, cosine of alpha, times cosine of the second angle, which is negative beta, minus sine of the first angle, which is alpha, times sine of the second angle, which is negative beta. All right, here's what I got to do. In the end, I got to end up with this statement right here. I got to end up with that statement. I don't have it yet, but here's how I got to go forward. Now, if you notice in that statement, you don't see any negative betas. You don't. So we got to somehow convert those. Well, this is where we use our cofunction relationships. Or no, our even and odd identities. Sorry. Our even and odd identities. Now, you don't need to write this down as part of your proof, but here's the case. Cosine of negative beta, since it's an even function, is the same as cosine of beta. And the sine of negative beta, since it's an odd function, is negative sine of beta. So I can go here and I'm going to start with cosine of alpha minus beta equals. This cosine of alpha doesn't change. Cosine of negative beta can be replaced with cosine of beta. Minus sine of alpha doesn't change. Sine of negative beta gets replaced with negative sine beta. All right, I'm almost done. So cosine of alpha minus beta is equal to cosine of alpha times cosine of beta. All right, here's the step here. This is negative sine of alpha times negative sine of beta. Make sure you put those parentheses there so it doesn't look like a subtraction. You're multiplying those. And what's a negative times a negative? A negative times a negative is a positive. So right there, there's your formula for a minus sign. Cosine alpha. Let's see if I can get this on here. Yep. Cosine alpha, cosine beta, plus sine alpha, sine beta. Not that you have to write it, but Q, E, D. Now we typically prove the next two, but since I'm not there and I just don't think it's going to be a good thing to do. You need to know this one. When I get back, we'll talk about the other two possibly, but for right now, we're just going to accept those to be true. So this leads us to our sum and difference formulas. With the deal with cosine and sine, we're not going to worry about deriving the tangent ones. There's the formulas. We will use the formula, but you do not have to derive it. So have your identity sheet, your formula sheet handy so that we can at least look through or use these ones here. All right, now that we know how to use it or where it comes from, here's how to use it. All right, so an example. We did that first one, which was what, 75 degrees. Let me go backwards for a second. So the exact value for cosine of 75 degrees. We can now do other angles other than just 30 and 45 and multiples of 35. And that's kind of what we're doing, is just try and figure out ways to get as many angles as we can. So the next one we're going to do is 195. What you have to do, or what we have to do, is represent it in terms of angles that we already know. And those are any unit circle angles. So I can write that as sine of 240 minus sine of 45. Those aren't the only two angles that work. You could have represented it as the sine 150 plus 45. It doesn't matter. It's going to give us the same answer. So we have that, but we're going to choose 240 minus 45. Well, since that's a minus sign, if you look at your identity sheet, the sign of alpha minus beta, okay, is equal to the sine of the first angle times the sine of the second angle plus the cosine of the first angle times the sine of the second angle. We did not derive that one, but we're going to use it. So now what I have is the sine of 240, sine of the first, times the cosine. Whoops, I think I said it, but I didn't write it right. Cosine of the second angle. What did I do wrong here? Oh, I copied down the wrong angle. Oh, crap. Hold on. That's going to make you guys screw you up. Sorry. All right, hold on. So sine. Look at your sheet better than I did. Of alpha minus beta is sine of the first times cosine of the second minus cosine of the first times sine of the second. So that's what we got here. Sine of the first, cosine of the second, minus cosine of the first, sine of the second. You know how to calculate these. What is the sine of 240? Okay, the sine of 240. That's going to give you a reference angle of 60 degrees. That's going to be your opposite side the sine is, which is square root of 3 over 2. Since it's in quadrant 3, it's going to be negative. Okay, so it's going to be negative square root of 3 over 2. Cosine of 45 degrees, that is going to be positive square root of 2 over 2. Minus, what's the cosine of 240? Well, we just had that figure drawn. That's, again, a reference angle of 60. That's going to be square root of 3 over 2. That's going to be 1/2. So the cosine of 240 is going to be negative 1/2. And then the sine of 45 is square root of 2 over 2. All right, so now it gives me negative, if I multiply these together, square root of 6 over 4 minus, minus the negative will give me a plus square root of 2 over 4. So the only thing I can do here is negative square root of 6 plus square root of 2 all over 4. Now, a lot of times you'll see it written with the positive one first. These are all equivalent, doesn't matter. But that's my answer. Would we say that is the sine of 195? If I wanted to double check it, I'd hit sine 195. Okay, negative 0.2588. And then, hold on here. If I want to type this all in at once, I have to use parentheses. Divided by 4. Okay, I get the same answer. So there I can just verify that I'm correct for that. Now, all of these answers are going to look very, very similar. You're going to have typically a square root of 2, a square root of 6 over 4. It's just going to be which one's plus or minus. Okay, they're all going to be similar because all of these unit circle angles deal with square root of 3 over 2, square root of 2 over 2, and 1/2. Okay, so they are all going to be very similar in their answers. All right, let's take a look at another example. All right, cosine of pi over 12. What we need to do is write this in terms. Now, this tends to throw people off because it's pi over 12. And I at least need to cover it in radians so that we know what's going on. All right, here's how you can do this. We know the answers for pi over 6, which is 30 degrees, pi over 4, and pi over 3. Well, I'm going to give these common denominators of 12. That's 2 pi over 12. 3 pi over, and that's not a 3. That should be a 12. And then that should be 4 pi. All right, how can I use any of these three to get pi over 12? I can either subtract 3 pi over 12 minus 2 pi over 12 or 4 minus 3. It doesn't matter. Let's do those two right there. So here's what I can do. I can take cosine of pi over 12. And it's going to be the same as cosine of pi over 4 minus pi over 6. And don't forget, pi over 4 is 45 degrees. Pi over 6 is 30 degrees. If you want to think of those in degrees, that's fine. All right, what is the formula for cosine of alpha minus beta? Use your sheet for now. What is the formula for cosine of alpha minus beta? It is cosine of the first times cosine of the second plus sine of the first times sine of the second. Now I'm just going to use this formula, but I'm going to plug in pi over 4 for the first and pi over 6 for the second. So cosine of pi over 4 minus pi over 6 is cosine of pi over 4 times cosine of pi over 6 plus sine, that's a 6, of pi over 4 times sine pi over 6. All right, what's the cosine of pi over 4? Well, that's the cosine of 45 degrees. That is square root of 2 over 2. What's the cosine of pi over 6? That's the cosine of 30 degrees. That's square root of 3 over 2. Plus, what's the sine of 45 degrees? Square root of 2 over 2. And the sine of 30 degrees, which is 1/2. So that gives me square root of 6 over 4 plus square root of 2 over 4, which is square root of 6 plus square root of 2 over 4. Like I said, these answers are all going to be very, very, very similar. If you, we can't plug it in. Well, pi over 12, figured it out. It's really 15 degrees. So if you wanted to double check that, you can just plug in cosine of 15 degrees. And then I can plug in square root of 6 plus square root of 2. And that would be all of that divided by 4. Okay, same thing. So we are good there. We are good. Now, for most of them, there's going to be degree measures. There will be some where there's radians, and it's helpful when it's radians to get a common denominator for the kind of the three basic ones and then figure that out. Okay, or, to give an idea. All right, your homework or classwork, make sure you get this done in class as much as you can. Is page 641, and just these 5 problems. Well, 9 and 11 answers in the back. Here's 14, 18, and 24. See how they're all similar, just to give you an idea to make sure you feel okay about your final answers. All righty. I will be back on Tuesday, and then you'll probably have something similar on Monday. All right, best of luck. Have a great weekend. And let me turn this thing off. Let me see.